Chapter 13 Sound. We heard different kinds of sounds during our working hours. These sounds come at us from all directions from our surroundings. These sounds are produced by both living beings as well as non-living things. We recognize quite a number of them without the need to actually see their source. This is because we have already acquired this knowledge. If we hear a dog barking at the distance, we know it is a dog barking, even when we are not seeing it. Similarly, when you receive a telephone call, you know at once your friend is online as soon as you hear the voice. When you are in music room of your school, you hear different sounds of musical instruments like flute, harmonium and tabla etc. This is because the sound produced by each one of us has a different character. How is sound produced? How does it travel from one place to another? How do we hear sound? Why are some sounds louder than others? We shall discuss such questions in this chapter. Sound is produced by a vibrating body. Do you hear the sound of school bell? Touch the school bell when not in use. Now strike with a stick again. Touch it when producing sound. Do you feel the vibration? As you learnt in class 7, the to and fro or back and forth motion of an object is called vibration. When a tightly stretched band is plucked, it vibrates and produces sound. When it stops vibrating, it does not produce any sound. We see that a vibrating object produces sound. In some cases, the vibrations are easily visible to us. But in most cases, their amplitude is so small that we cannot see them. However, we can feel them. Make a list of musical instruments which you know very well. Identify their vibrating parts. A few examples are given in table 13.1. Complete rest of the table. Many of you might have seen the manjira, cymbals, the ghatam, and the note, mud pots, and the kartal. These musical instruments are commonly used in many parts of our country. These instruments are simply beaten or struck, figure 13.6. Can you name a few other musical instruments of this type? You too can make a musical instrument. Sound produced by humans. When we speak loudly, which part of our body vibrate? Put your hand on your throat. Do you feel any vibrations? In human being, sound is produced by a voice box, larynx. Two vocal cords are stretched across the voice box such that a passage for air remain between the cords. When we speak, lungs force air through passage, due to which the cords start vibrating and produce sound. The tightness of the cord are controlled by the muscles which are connected to the vocal cords. When the vocal cords are tight and thin, the type or quality of voice is different from that when they are loose and thick. Let us see how the vocal cords function. Sound needs a medium for propagation. The traveling of sound is called propagation of sounds. Sound cannot propagate in the absence of a medium. When you call your friends who is standing at a distance, your friend is able to hear your voice. How does the sound propagate or travel to her? Can you think of an explanation? Is it possible that the decreasing amount of air in the tumbler had something to do with decreasing loudness of the ring? Indeed, if you had been able to suck all the air in the tumbler, you will not listen any sound. Actually, sound needs a medium to travel. When air has been removed completely from a vessel, it is said that there is a vacuum in the vessel. The sound cannot travel through a vacuum. Does sound travel in liquids? Let us find out. Let us find out if sound can travel through solids also. Solids have tightly packed particles in them and hence they allow fast propagation of sound through them, as the vibration can be carried easily from one particle to another. You can also perform the above activity by placing your ear at one end of a long wooden or metallic table and asking your friend to gently scratch the other end of the table. We find that sound can travel through wood or metal. In fact, sound can travel through any solid. You can perform interesting activities to show that sound can also travel through strings. Have you ever made a toy telephone? Figure 13.14. Can you say that sound can travel through strings? We have learned so far, and vibrating objects produce sound and it is carried in all direction in a medium. The medium could be a gas, liquid or a solid. How do we hear it? We hear sound through our ears. We know that sound are produced waves in the air or any other medium. As these sound waves traveled to our far, they converted them into electrical signals or messages that our brain can understand. Our ears have a special structure that allows. The shape of the outer part of the ear is like a funnel. When sound enters it, it travels down a canal at the end of which a thin membrane, tympanic membrane, is stretched tightly. It is called the eardrum. It performs an important function. To understand what the eardrum does, let us build a tin can model of the eardrum. The eardrum is like a stretched rubber sheet. Sound vibrations make the eardrum vibrate. Figure 13.16. The eardrum sends vibrations to the inner ear. From there, the signal goes to the brain. That is how we hear. Amplitude, time period and frequency of a vibration. We have learned that the to and fro motion of an object is known as vibration. This motion is also called oscillatory motion. You have already learnt in earlier classes about the oscillatory motion and its time period. Frequency describes the number of waves that pass a fixed place in a given amount of time. Usually frequency is measured in the Hertz unit. A frequency of 1 Hertz is 1 oscillation per second. If an object oscillates 20 times in 1 second, what would be its frequency? You can recognize many familiar sounds without seeing the objects producing them. How is it possible? These sounds must be different to enable you to recognize them. Have you ever thought what factors make them different? Amplitude and frequency are two important properties of any sound. Can we differentiate sounds on the basis of their amplitudes and frequencies? Loudness and pitch. The loudness of sound depends on its amplitude. When the amplitude of vibration is large, the sound produced is loud. When the amplitude is small, the sound produced is feeble. Compare the sound of a baby with that of an adult. Is there any difference? Even if two sounds are equally loud, they differ in some way. Let us see how. I wonder why my voice is different from that of my teacher. The frequency determines the shrillness or pitch of a sound. If the frequency of vibration is higher, we say that the sound is shrill and has a higher pitch. If the frequency of vibration is lower, we say that the sound has a lower pitch. For example, a drum vibrates with a low frequency. Therefore, it produces a low-pitched sound. On the other hand, a whistle has a high frequency and therefore produces a sound of higher pitch. Figure 13.18. A bird makes a high-pitched sound whereas a lion makes a low-pitched roar. However, the roar of a lion is very loud while the sound of the bird is quite feeble. Every day you hear the voices of children and adults. Do you find any difference in their voices? Can you say that the frequency of the voice of a child is higher than that of an adult? Usually the voice of a woman has a higher frequency than that of a man. Audible and inaudible sounds. Do you know that we hear different kinds of sounds around us? Sound that can be heard by human ears are called audible sounds. The range of audible sounds is from 20 Hz to 20 kHz. Similarly, sounds that cannot be heard by human ears are called inaudible sounds. Thus, for human ear the range of audible frequencies is roughly from 20 to 20,000 Hz. Noise and music. As you know, we hear different types of sounds which are present around us. The sound is always pleasant to us. Some sound are pleasant to the ear whereas some are not. Noise can be regarded as unpleasant sound. Noise consists of sound waves of various frequencies which have no particular period pattern of repetition. Therefore, noise is regarded as a mixture of sound waves with irregular frequencies. Suppose construction work is going on in your neighborhood. Are the sounds coming from the construction site pleasing? Do you enjoy the sounds produced by horns of buses and trucks? Such unpleasant sounds are called noise. In a classroom, if all the students speak together, what would the sound produced be called? Music, on the other hand, is a pleasant sound that has a clear pitch. Musical sound can be created by arranging and marking different sound in a particular order. The frequencies of a musical sound are harmonious in nature. But, if a musical sound becomes too loud, would it remain melodious? Noise pollution. You have already learnt about air pollution. Similarly, noise pollution can be defined as the presence of undesirable and unpleasant sounds in the air. Generally, any sound that has a frequency of more than 30 decibels is considered noise. Can you list some sources of noise pollution? Major causes of noise pollution are sounds of vehicles, explosions including bursting of crackers, machines, loudspeakers, etc. What sources in the home may lead to noise? Television and transistor radio at high volumes, some kitchen appliances, desert coolers, air conditioners, all contribute to noise pollution. What are the harms of noise pollution? Do you know that the unwanted noise causes an adverse effect on the health of the organisms present on the earth? Excessive noise in the surroundings can lead to serious health problems such as hypertension, lack of sleep or insomnia, anxiety, lack of memory, stress, irritation and even nervous breakdown. It can lead to temporary or permanent hearing loss in human beings as well as animals. Measures to limit noise pollution. We have to pay attention to control noise. Factories and other industries should be set up at a distance from residential areas. Silencing devices sound be incorporated into heavy vehicles such as aircraft, industrial equipment, machinery and other home appliances. Use of horns should be minimized, especially near public places such as hospitals, religious places and schools. Soundproofing systems should be installed in industries, party halls and other buildings that produce a high amount of unwanted sounds. TV and music systems should be run at low volumes. Trees must be planted along the roads and around buildings to cut down on the sounds reaching the residents, thus reducing the harmful effects of noise pollution.